In this video, we're going to learn how to factor a sum and a difference of cubes. So a sum of cubes is in this type of form where you have a to the third power plus b to the third power, and sum meaning that there's going to be addition between two terms. We can factor this apart using this form that will have the a plus b in one parenthesis times a squared minus ab plus b squared. The other form, a difference of squares, will be of this form. A difference means subtraction, so there will be subtraction between our two terms. That can be factored apart into the following form: a minus b times a squared plus ab plus b squared. What I want you to notice is that all the terms in our parentheses, whether it's a sum or a difference of cubes, are all the same. We have a and a b in the first parenthesis. We have a squared, ab, and b squared in the second parenthesis. The only thing that changes are the signs that are between the terms. What's an easy way to get these to memorize these? Well, if you have a sum of cubes, the first parenthesis will always be a plus sign, followed by minus plus. If you have a difference, the first sign will always be a minus sign, so it will go with the sign that's in the original problem, followed by two addition signs. So you will always have two addition signs and one subtraction. If you write that plus sign first, then it will be minus plus. If you go ahead and write that subtraction sign, the rest are your plus signs. So there's always two additions and one subtraction. How can we be successful factoring a sum or a difference of cubes? 3 simple steps. The first step, and we do this with any factoring, is you always look for a greatest common factor. See what the terms have in common, take it out, make the problem easier on yourself. Step 2, identify if that polynomial is going to be a sum or a difference of cubes. Look between the two terms. Do you have a plus sign? Do you have a subtraction sign? That'll tell you which factored form you're going to use. In step 3, you need to find the a and the b, and we're going to plug it into that appropriate factored form. That appropriate form is either the sum or the difference of cubes. So let's try 4 examples. Directions say, factor each polynomial. If that polynomial cannot be factored, write prime. In our first example, we have 16x to the fourth plus 54xy to the third. Go with the steps. Always look for greatest common factors. Well, both 16 and 54 are even, so there's definitely a common divisor between those two. We also have x in the first term, we have x in the second term, so they have a common factor of at least an x. That common factor is 2x. And then let's use the distributive property to fill this back in, knowing that if you were to take this 2x and distribute it through, you should get 16x to the fourth back. 2 times 8x to the third gets you back to 16x to the fourth. Then 2x times something gets you back to 54xy to the third. That something is 27y to the third. Now we're going to not focus on the 2x anymore. We're going to look at this part, because what you see is we have an x to the third and a y to the third in here. This looks like it could be a sum of two cubes. Why do I know it's a sum? There's a plus sign between them. So that red parenthesis should factor apart into this form. Now there's a's and b's in this. We need to figure out what that a is and what that b is. In our original form, it's a cubed plus b cubed, so we're going to start with saying the a cubed is represented by the 8x to the third. I can find the a by cubed rooting both sides. A cubed root will cancel out the third power, so a would equal, well, we're going to say 2x. Now why is it 2? Remember that a cubed root is saying what number times itself 3 times would get you 8. Well, that's 2 times 2 times 2, so the cubed root of 8 is 2. And we can also find this by typing it into our calculator. The cubed root will cancel out the third power on the x, so the a is just a 2x. Do the same thing for b to the third power. B to the third would equal 27y to the third. We cube root both sides, thinking what number times itself is 3 times is 27. That number is going to be 3. The cubed root will cancel out the third power on the y, so we have b equals 3y. Now I'm going to go right back to this entire factored form here. Wherever there's an a, I put a 2x. Wherever there's a b, I put a 3y. So going back to this, originally we factored out a 2x. Now my a is 2x. We have a sum, so the first side is going to be a plus. Y, 3y. And then in the second parenthesis it says let's do a squared. So I have to plug in 2x to the second power, followed by the minus sign. And then 2x times 3y, because that's a times b, and then finally plus b squared, so 3y squared. We'll have to go in and then simplify all of this stuff here. So when I do 2x squared, we have to square the 2 and the x to get the 4x squared. We take the 2x times the 3y, 2 times 3 gets us the 6xy. And then finally, the last term, 3y squared. 3 squared is 9, and we get y squared, and this right here is the factored form of this polynomial right here. So yes, we're taking a smaller problem and we're stretching it out, because eventually we'll figure out what the x's and the y's are equal to. Another example, 8y to the third plus 5x to the third. So I look through, go through my steps. Do I have anything like between the terms here that I could factor it out and make it smaller? Well, 8's even, 5 is odd. Definitely can't factor anything out of those two numbers other than 1. The first term has a y, the second term has an x, so there's no variables in common. So we'll move on to the next step. Is it a sum or a difference of cubes? Well, I look between the parentheses, the terms, there's a plus sign, so then it looks like it could be a sum of cubes. So now let's find out that a and the b value. Take a to the third equal to 8y to the third. Cube root both sides. The cube root of 8 is 2, and the cube will cancel out the third power. So a would be 2y, so all good so far. Finding the b value. B to the third would be 5x to the third, and then we try to cube root both sides. But what you're going to find out is when you type this into the calculator and you do cube root of 5, you're going to get a nasty decimal, which means 5 is not a perfect cube. So this does not have a true b value that we're going to be able to plug into this. So what we're going to say here is that this problem is already factored as much as you can get. It's called prime. Remember that a prime number, by definition, its only factors are the number and itself. Well, the polynomial works the same way. The only thing that you could factor out of this entire polynomial is the number 1, which leaves you with the original problem itself. So this is a prime polynomial. So sometimes these do not factor any further, even though that it looks like it could be a sum of cubes. Okay, 2 more examples to get through. Now we have example 1a, 5y to the fourth minus 320y z to the third. Look for common factors. You will see that, hey, this is 5, this ends with a 0, so definitely we could factor out a 5. We have a y to the fourth and a y in this term, so we can take a y out of it. So our greatest common factor would be 5y. So what's left over? Well, 5y times something is going to give us 5y to the fourth back. That something is y to the third. 5y times something is negative 320 yz to the third. That something will give you negative 64z to the third. So now we focus on what I have in green. That looks like it could be a difference of cubes. So now the factor form that we're going to focus on is this one. Still finding the a and the b. So the a would be our y to the third, or actually our a to the third would be our y to the third. And we cube root both sides, which will cancel out all the third powers. So a is going to be replaced with the letter y. Set b to the third equal to 64 z to the third. Cube root both sides. And the cube root of 64 is 4. The third power gets canceled out by the third root. So b would equal 4z. So everywhere that you see an a, you put a y. Everywhere you see a b, you put a 4z. So we go through, we originally factored out 5y, and then what we have in green turns into a, or in other words y, minus the b value, which is 4z, and then a squared plus a times b plus b squared. Simplify everything that you have in here, which will give you this final factored form. 5y times y minus 4z times a parenthesis of y squared plus 4yz plus 16z squared. Now, what I will say is in the future, we normally will not write out all this work here, but I'm doing it for the purpose of the video so you can see where everything is coming from. We'll usually be able to go straight from this step down to this step to get our answer. Okay, so one last example. Negative 54w to the fourth minus 250wz cubed. So we go again, look for our greatest common factors. And also, don't always just look for positive common factors. If you can take out a negative common factor, that would be great. So our common factor here is going to be negative 2w. They're both even, so we look for even numbers to factor out. What's that going to leave us with? Well, negative 2w times something, again, should get you back to negative 54w to the fourth. That something is 27w to the third. Negative 2w times something gets back to negative 250w to the third. That something is going to be a positive 125z to the third. So what's really important about this is, even though you have the minus sign here, it looks like it could have been a difference of cubes. Because we factored out that negative, now it turns into a sum of cubes. So we'll use this factored form. Let's take this 27w to the third, set it equal to a to the third. Cube root both sides. The cube root of 27 is 3, and the cube root will cancel out the third power, so everywhere we have an a, we place it with a 3w. Do the same thing for b to the third. What's the cube root of 125? That would be 5. And the cube root of z to the third would be z, and everywhere I see a b, we put a 5z. So here's how we normally would work these out. We take out what we originally our common factor, what we originally factored out, and then we go with a, the sum, so it'll be plus the b value. And now when we fill in what comes after this parenthesis, we're going to start with this. We're going to square it, so 3 times 3 would be 9. And w times w is 9 squared, so w squared. So there's first term. Because we wrote the plus sign originally here, this one should be a negative. And then we just take 3w times 5z. 3 times 5 gives us that 15. And w times z is wz. And then finally, we'll take that last term, 5z, and square it. So 5 times 5 is 25, and z times z is z squared. And there you have it. There's the complete factored form of this polynomial. All right, so now you know how to factor a sum of cubes and a difference of cubes. You can